Hello, I'm Scott Bryce, owner and developer of the Math Worksheet site, and this is my introduction to trigonometry. Trigonometry is all about one particular geometric shape. What shape is that? We can get a clue from the word itself. Tri means 3, gon means side, and metry means measure. So we have the measure of three-sided figures. You might conclude from that trigonometry is, first and foremost, about triangles, and you'd be wrong. Trigonometry is, first and foremost, about circles. Specifically what we call a unit circle. A unit circle is a circle drawn on a coordinate plane with its center on the origin and a radius of 1. 1 what? We really don't care. 1 inch? 1 foot? 1 unit that equals 3.7 miles. 1/2 the distance from Los Angeles to New York. We really don't care. Whatever the distance is, we call that 1. Now trigonometry asks a particular question. If we start at the point where the circle crosses the x-axis on the positive side at 1, 0, and move along the circle in a counterclockwise direction a particular distance, at what point will we end up? We measure this distance in units that are equal to the radius of the circle. That's why we call them radians. 1 radian along the circle is equal to 1 radius of the circle, only we're moving in a circular path and not in a straight line. And we give this distance a name. We call it theta, which we represent with the Greek letter theta. So where do we end up? For some values of theta, the answer is easy. We know that the circumference of the circle is 2 times pi times the radius of the circle, and 1 radian equals 1 radius. So if we travel a distance of 2 times pi radians, we wind up right back where we started, at 1, 0. You will notice that when we travel around the circle 2 pi radians, we traveled 360 degrees around the circle. There's a direct correlation between radians and degrees. 2 pi radians is the same as 360 degrees. You will also notice that if we traveled twice around the circle, a distance of 4 pi radians, we would wind up in the same place. And if we traveled in the opposite direction, a distance of negative 2 pi radians, we would also wind up in the same place. Now let's say we traveled half the distance around the circle, a distance of pi radians. We would wind up at negative 1, 0. You can also see that we've traveled 180 degrees around the circle. If we travel half that distance around the circle, a distance of pi over 2 radians, we wind up at 0, 1. If we travel half of that distance, things get a little harder. Where do we end up if we travel pi over 4 radians around the circle? To figure that out, let's draw a line segment from the origin of the coordinate plane to our point on the circle. Let's draw another line segment from the origin to a point on the x-axis directly below our point on the circle. Let's draw a third line segment from our point on the circle to our point on the x-axis. Now we have a triangle. And we can begin to understand the relationship between our unit circle and triangles. We can label the sides of the triangle A, B, and C, with C being the longest side. There's some things you'll notice about the triangle. First, it's a right triangle. Next, the angle with its vertex at the origin of the coordinate plane measures 45 degrees. This means that our third angle is also 45 degrees. The length of side A is the x value of our point on the circle. The length of side B is the y value of our point on the circle. The length of side C is the same as the radius of the circle. Since we have two angles with the same measure, we have an isosceles triangle, which means that sides A and B have the same length. What is that length? Since we have a right triangle, we can ask Pythagoras for help. He will tell us that a squared plus b squared equals c squared, and leave us to work out the rest on our own. We know that the length of side C is 1 radius, and our radius has a length of 1. So let's plug that into our formula. A squared plus b squared equals 1 squared, which equals 1. We also know that side A and side B have the same length, so we can rewrite our formula as 2a squared equals 1. Divide both sides by 2, and we have a squared equals 1/2. Take the square root of both sides, and we have a equals the square root of 1/2, which equals the square root of 1 over the square root of 2, or 1 over the square root of 2. Mathematicians don't like square roots on our denominators, so we multiply our fraction by 1 in the form of radical 2 over radical 2 and get a equals radical 2 over 2. Side B has the same length as side A, so it's also radical 2 over 2. Remember that the x value of our point on the circle is the same as the length of side A on our triangle, and the y value of our point on the circle is the same as the length of side B on our triangle. So our point is radical 2 over 2, radical 2 over 2. Let's try another one. What if the distance we travel around the circle equals pi over 3? Let's draw our triangle the same way we did before and see what we can learn. First, what's the measure of the angle with its vertex at the origin of the coordinate plane? We know that there's a direct correlation between radians and degrees, and that pi radians is the same as 180 degrees. So pi over 3 radians is the same as 180 over 3 degrees, or 60 degrees. We know that the angle sitting on the x-axis is 90 degrees. That makes our third angle 30 degrees. The length of side C is 1 radius, which is 1 unit. You may recall from your geometry that a 30, 60, 90 triangle has a special property, and that is that the length of the shortest side is exactly 1/2 of the length of the longest side. That means that side A has a length of 1/2. What's the length of side B? Again, since we have a right triangle, we can turn to Pythagoras for help. Let's plug the values we know into the Pythagorean formula. A equals 1/2. We don't know the value of B. C equals 1, so 1/2 squared plus B squared equals 1 squared. We can simplify that to 1/4 plus B squared equals 1. Subtract 1/4 from both sides, and we have B squared equals 3/4. Take the square root of both sides, and we have B equals the square root of 3/4, which we can rewrite as the square root of 3 over the square root of 4. That simplifies to radical 3 over 2. So the length of side A is 1/2, and that's the x value of our point on the circle. The length of side B is radical 3 over 2, and that's the y value of our point on the circle. So our point on the circle is 1/2 radical 3 over 2. In trigonometry, we give these values names. We already know that the distance we travel around the circle is called theta. We represent that with the Greek letter theta. When the radius of the circle is 1, we call the x value of the point on the circle the cosine. We call the y value the sine, and we write it like this. For theta equals pi over 3, cosine theta equals 1/2. Sine theta equals radical 3 over 2. Or we can write it like this. Cosine pi over 3 equals 1/2. Sine pi over 3 equals radical 3 over 2. We also have another value we give a name to. The tangent of theta is the sine of theta over the cosine of theta. That means that the tangent of theta equals the y value of our point on the circle over the x value of the point. The y value is the distance above the origin, the x value is the horizontal distance from the origin, so the tangent is the rise over the run, which is the same as the formula for the slope of a line. In our diagram, the tangent is the slope of the hypotenuse of the triangle. So what happens if the radius isn't 1? Let's suppose it's 3. What happens then? What happens is that everything gets bigger by a factor of 3, and we need to fine-tune 2 of our terms so that everything scales back down. We need to think of our radius as 1 unit that's 3 big. Now our formulas look like this. The cosine of theta is the x value of our point on the circle divided by the radius. The sine of theta is the y value of our point on the circle divided by the radius. The tangent of theta is still the y value divided by the x value. So what does that mean? If we take our formulas and multiply both sides by the radius, this is what happens. If we know the value of theta and we know the radius of our circle for our point xy on the circle, x equals the cosine of theta times the radius. Y equals the sine of theta times the radius. And tangent of theta equals the sine of theta over the cosine of theta. In trigonometry, we often work with right triangles. So what happens if you're given a right triangle and not a circle? Simple. Imagine, or draw a diagram if you need to, the triangle sitting on a coordinate plane, with the vertex of the angle you know sitting on the origin of the coordinate plane. That's your theta. Have the right angle sitting on the x-axis. Now draw a circle around the whole thing so that the center of the circle is the origin of the coordinate plane, and the circle passes through the vertex of the third angle of the triangle. The radius will be equal to the length of the hypotenuse of the triangle. Now the trigonometric ratios are easy to see: the cosine, the sine, and the tangent, which is also the slope of the hypotenuse. The length of side x will be the cosine of theta times the radius. The length of side y will be the sine of theta times the radius. But often all you have is an angle and a length. We call these vectors. Imagine, or draw a diagram, a coordinate plane with a circle centered on the origin with a radius the same as the length of the vector. Draw the vector so that your theta, the angle you're given, is the angle between the x-axis on the positive side and the vector. This will give you your point on the circle. Draw a line segment from the point on the circle straight down to the x-axis. Draw a line segment from this point on the x-axis back to the origin. Now the trigonometric ratios are easy to see: the cosine, the sine, and the tangent. The x value will be the cosine of theta times the radius. The y value will be the sine of theta times the radius. The slope of the vector will be the tangent, which will be the sine of theta over the cosine of theta. As you can see, it's possible, depending on the value of theta, for the cosine, sine, or tangent to be a negative number. In this example, the vector ends in the second quadrant, which means that the x value, the cosine, will be a negative number, and the tangent will also be negative. I'm Scott Bryce, owner and developer of the Math Worksheet site, and this has been my introduction to trigonometry.